Welcome to the WION podcast. Today we're diving into some really significant developments with India's human spaceflight mission, Gaganyaan.
That's right. Big news coming out of ISRO.
Yeah, specifically about the engines, the propulsion system for the crew capsule. It's a major milestone.
Absolutely.
So our goal today is, well, to unpack these recent tests and figure out what they really mean for the mission going forward.
Sounds good. It's all about building confidence piece by piece.
Exactly. So the headline is, ISRO ran some important tests for Gaganyaan. What exactly were they testing?
They were testing the Gaganyaan Service Module Propulsion System, the SMPS.
SMPS, okay.
Yeah, this happened down at the ISRO Propulsion Complex in Mahendragiri, Tamil Nadu. That's their main hub for this kind of work.
Right. And what did these tests actually involve? Were they long burns or more like quick checks?
They did two short tests, hot fire tests. One was for 30 seconds, and the other ran for 100 seconds.
Okay, short bursts then.
Yeah, relatively short. But the key thing is they successfully validated the system setup, its configuration, and, confirmed everything performed normally. That's a really positive sign.
Good start. And this SMPS system, how complicated is it? What are the components?
Well, it's pretty intricate. You've got 5 main engines, the liquid apogee motors, or LAM engines.
Those main ones.
And then 16 smaller thrusters, the reaction control system, or RCS thrusters.
16.
Yeah. And in that 100-second test, they actually fired all of these, the main engines and the RCS thrusters simultaneously.
All at once?
Yeah, in different modes too, some steady firing, some pulsing for finer control. It was a big demonstration of the whole integrated system working together.
Okay, so it's clearly a complex piece of kit. What's its actual job on the Gaganyaan mission? Why is it so critical?
Well, its main role is orbital maneuvering. So changing the capsule's orbit once it's in space, and also orientation control, like pointing the capsule correctly. Plus, it's vital for certain abort scenarios.
Ah, right. Getting the crew away safely if something goes wrong.
Exactly. It's the spacecraft's engine and steering, essentially.
Now, thinking about these engines, I seem to recall there was an issue, wasn't there, with a similar type of engine on a recent satellite mission?
Yes, that's a very relevant point. Back in January, the NVSO2 satellite had a problem. Its main engine, which is actually the same type of 440 Newton LAM thruster used here in the Gaganyaan SMPS, it failed to fire.
Oh, right. What happened there?
The investigation found that the valves needed to let the oxidizer into the engine didn't open properly, so the satellite got stuck in its transfer orbit.
Okay, so not ideal. Given that background, this successful Gaganyaan test seems, well, even more important.
Absolutely. It's a huge confidence booster. It shows ISRO has likely understood the previous issue and addressed it.
Have they mentioned specific changes?
Yes, they've stated they're implementing hardware and software changes based on the lessons learned. They're also adding more checks, more reviews, beefing up the verification process. It shows they're taking that previous issue very seriously, especially with humans involved this time.
That's reassuring. Rigorous testing is key. So what's next for Gaganyaan after this? Is this the final hurdle for the propulsion system?
Oh, no, not at all. This is just one test among, well, thousands planned for the whole mission. The next big step for this specific system is a full-duration hot test, so running it for much longer.
Okay.
And then, crucially, before any astronauts fly, ISRO plans at least 3 successful uncrewed missions.
3 test flights without people.
Exactly. They'll fly with a humanoid robot called Viomitra on board to simulate the crew. These flights will test everything, right up to the splashdown landing in the ocean.
So step by step, building up the complexity and the proof.
Precisely. It's all about methodical testing and learning.
Well, this deep dive certainly shows ISRO making a really confident stride forward, wouldn't you say? Building on experience, rigorous testing. It looks promising for India's human spaceflight goals.
Yeah, it really does. And when you think about it, the sheer effort and the level of precision needed to keep humans safe in space, it's just monumental. It's an incredible challenge they're tackling.
Absolutely incredible. Well, that's all we have time for on this deep dive. Thanks so much for tuning in, and do stay tuned for more such intriguing stories to come.